600 million years ago, Earth was a place beyond anything we could recognize today. The continents, scattered across the globe, were barren wastelands of rock and dust. No grass covered the ground. No trees reached toward the sky. Not a single animal or insect crawled across the land. The wind howled over endless stretches of lifeless terrain, and rain fell on bare stone, carving rivers and valleys that would remain empty for millions of years. The oceans, however, told a different story. Beneath the waves, life had already begun its long and patient experiment. In the deep, quiet seas, strange and delicate creatures floated in the currents. They were soft-bodied, without bones, shells, or hard parts. Forms like Dickinsonia and Charnia lay flat against the sea floor, absorbing nutrients directly from the water or sediment. Others, resembling fronds or discs, anchored themselves lightly to the seabed, swaying with the tides. These organisms belonged to a world so primitive that the very concept of predator and prey barely existed. It was a time before jaws, teeth, or armor. Survival meant existing in harmony with the surrounding environment, rather than battling against it. The atmosphere above was slowly changing, though not yet ready to support complex life on land. Oxygen levels were rising, thanks to photosynthetic microorganisms that had been quietly working for over 1 billion years. Vast colonies of cyanobacteria had produced enough oxygen to tip the balance, creating the potential for more energetic, more complex life forms to evolve. But on land, the air remained harsh. The ultraviolet radiation from the sun, only partially blocked by the developing ozone layer, scorched the surface relentlessly. It was an empty, hostile place, waiting for life to find a way to cross the boundary from sea to shore. The continents themselves were in motion, carried by the restless forces beneath the crust. Volcanic activity was common, shaping the landscape with eruptions and lava flows. Mountains rose and were worn down by endless rains. Vast, shallow seas flooded low-lying areas, creating new habitats for marine life. Earth was alive, not with forests and animals, but with the slow, grinding power of geology and the quiet persistence of early life. This ancient world was dominated by microbial mats, thin layers of bacteria and algae that coated rocks and seafloors. In some places, they built structures called stromatolites, growing upward toward the sunlight in shallow waters. These structures, humble though they seemed, were monuments to resilience, the earliest architects of life on Earth. Alongside them, the larger Ediacaran organisms floated, crawled and rested, each experimenting with new forms of existence. It is hard to imagine the beauty of these ancient seas. Sunlight filtering through clear, warm waters revealed a garden of ghostly forms, their bodies translucent and soft, like living shadows. Currents drifted lazily across the seabed, carrying particles of food and oxygen. There were no eyes yet to see, no nervous systems complex enough to understand, but life was beginning to shape its surroundings, carving out niches and testing the limits of possibility. This era, known as the Ediacaran period, lasted for tens of millions of years. It was a time of quiet innovation, a slow build-up to something extraordinary. Many of the creatures of this time would leave no descendants, their strange body plans disappearing forever. Others, perhaps, would lay the groundwork for future animals, though the path was anything but certain. Evolution was a chaotic artist, experimenting with shapes, sizes, and ways of living, most of which would end in dead ends. The Ediacaran world was not a paradise. Environmental stresses could still strike without warning. Ice ages came and went, covering much of the planet in glaciers and then retreating, leaving behind a churned and battered landscape. Volcanic eruptions poisoned the seas and the skies. Yet through it all, life endured. Each challenge forced new adaptations, and each extinction cleared the way for something new to emerge. By the end of the Ediacaran, around 541 million years ago, the stage was set for one of the most dramatic events in the history of life: the Cambrian explosion. The quiet, ghostly creatures of the Ediacaran seas would soon be replaced by a riot of color, movement, and complexity. Predators would rise, shells would appear, eyes would open, and Earth would never be the same again. But for those long eons, in a world without forests, without birds, without dinosaurs or mammals, life's story was written in the language of patience, resilience, and silent transformation. This was the beginning of everything we know, and the first chapter of a journey that would stretch across hundreds of millions of years, leading eventually to the vibrant, teeming world we call home. The Cambrian period dawned with a transformation so profound that it would echo through every living thing that would ever exist. For the first time, life leapt into complexity with a ferocity and speed that had never been seen before. The oceans, once home only to soft-bodied forms drifting in gentle currents, exploded into a chaos of new creatures, each equipped with strange and powerful adaptations. Earth's seas were now teeming with activity. Trilobites, armored and segmented, scurried across the ocean floor like miniature tanks, their exoskeletons glinting in the filtered sunlight. Some were hunters, while others scavenged or sifted through sediments for scraps of food. Above them, nimble, worm-like predators called Anomalocaris glided through the water with undulating grace, their flexible bodies and large, grasping appendages designed for seizing prey with compound eyes sharper than anything that had existed before. Anomalocaris was one of the earliest super-predators, changing the very nature of life in the oceans. This was the birth of ecosystems built on conflict. For the first time, creatures needed defenses against attack. Shells, spines, and hardened body parts evolved to protect against predators. Mobility became an advantage, and eyes appeared in various forms to spot both prey and danger. Creatures like Opabinia, with its 5 stalked eyes and bizarre proboscis, seemed like visions from a fever dream. Yet each was a masterpiece of evolutionary innovation. Beneath the shallow seas, reefs formed from the calcium carbonate structures built by early sponges and other reef-building organisms. The seabed became a crowded neighborhood of burrowers, grazers, hunters, and scavengers. Creatures carved out territories, competed for resources, and adapted to a world that was suddenly more dangerous, dynamic, and dazzlingly diverse. This explosion of life did not happen overnight. It built slowly over millions of years, but in geological terms, it was a blink of an eye. The fossil record from the Cambrian reveals a sudden and dramatic increase in both the diversity and complexity of life. Almost every major group of animals that exists today had their origins during this period. Arthropods, mollusks, annelids, echinoderms, and early chordates all traced their roots back to the Cambrian seas. The Earth itself supported this flourishing of life. Oxygen levels continued to rise, reaching a threshold that allowed for larger, more active animals. Shallow seas covered vast portions of the continents, providing warm, nutrient-rich environments ideal for sustaining complex ecosystems. Tectonic activity shifted the continents slowly, creating new coastlines, new habitats, and opportunities for isolation and innovation. Among the most remarkable of the Cambrian creatures were the early chordates, ancestors of all vertebrates. Small, simple, fish-like animals, with a notochord, a flexible rod running down their bodies, began to swim through the oceans. They lacked bones or jaws, but represented the first steps toward the evolution of animals like fish, amphibians, reptiles, birds, and mammals. The Cambrian explosion also introduced the concept of extinction on a grander scale. As competition intensified, many lineages that had once thrived began to vanish. Natural selection was now a relentless force, favoring the quick, the clever, the well-armored, and the adaptable. Life was no longer about simply surviving. It was about competing, succeeding, and sometimes failing in spectacular fashion. This new dynamic world set the blueprint for every ecosystem that would follow. Food chains became complex webs. Energy flowed through communities in ways that mirrored the intricate systems we see in modern forests, coral reefs, and savannas. Life became interconnected, and the fate of one species could influence countless others. The Cambrian oceans would have been a breathtaking sight. Coral-like sponges painted the sea floor in soft hues. Fields of worm burrows and trilobite tracks crisscrossed the sediments. Jellyfish-like creatures pulsed through the upper waters, while predators like Anomalocaris patrolled the depths with a quiet, lethal grace. It was a world alien and familiar all at once, a world where the fundamental rules of life as we know it were being written for the very first time. By the end of the Cambrian, around 485 million years ago, many of the great players of this early drama had either gone extinct or evolved into new forms. The stage was set for further expansion, greater complexity, and, inevitably, new disasters. Life had made its grand entrance onto the world stage, but its journey was only just beginning. In the silent ebb and flow of Cambrian tides, the seeds of future empires were sown. Every bird that would ever soar, every fish that would ever swim, every mammal that would ever walk the earth, all of them could trace their lineage back to these ancient oceans, where for the first time, life dreamed bigger, moved faster, fought harder, and dared to imagine a world beyond the simple existence of its ancestors. After the drama of the Cambrian explosion, life continued its relentless advance into the unknown. The Ordovician period began, and with it, the oceans grew richer, deeper, and more vibrant than ever before. It was a time when life built upon the foundations laid during the Cambrian, reaching new heights of diversity and complexity. The seas dominated the world, covering vast stretches of the continents under shallow, warm waters, turning the Earth into a planet of blue. Beneath these ancient waves, coral reefs began to take form. The first true coral builders, primitive rugose and tabulate corals, anchored themselves to rocky outcrops and shallow sea floors over generations. Their hard skeletons grew and layered upon each other, creating complex, living structures that provided shelter, food, and breeding grounds for countless marine organisms. These early reefs were smaller and simpler than the massive coral systems of today, but they represented a critical leap forward. For the first time, ecosystems had permanent, three-dimensional architecture. In the spaces between the coral structures, brachiopods, mollusks, trilobites, and crinoids thrived. The ocean floor bustled with life. Trilobites continued to dominate the sediments, now accompanied by armored relatives who developed spiny defenses against growing predation. Slow-moving gastropods grazed on algae, while filter feeders like bryozoans and graptolites extended delicate arms into the currents to capture microscopic food. The Ordovician seas were a world of contrasts, between the slow and the swift, the armored and the soft, the hunter and the hunted. One of the most remarkable innovations of this period was the rise of the first jawless vertebrates, the early fish. These ancient pioneers, called ostracoderms, swam cautiously through the seas, their bodies covered in protective armor plates. They had no jaws, relying instead on small circular mouths to filter food from the water or suck up organic material from the seafloor. Though simple compared to modern fish, these creatures marked a turning point. The age of vertebrates had begun. Fish were not the only predators to patrol the Ordovician oceans. Giant, squid-like creatures called orthoconies floated through the waters, their long, conical shells providing buoyancy and defense. Some grew to lengths of several meters, making them the largest animals on Earth at the time. With powerful tentacles and keen senses, they hunted smaller trilobites, mollusks, and early fish, casting long shadows across the reef landscapes below. Meanwhile, life continued to innovate in countless other directions. Early starfish crept across the seabed, their simple radial bodies hinting at the future splendor of echinoderms. Primitive plants began to appear along the coastal margins, tiny moss-like forms that clung to rocks exposed during low tides. Though barely noticeable against the backdrop of the ocean's grandeur, these early land plants would one day transform the face of the Earth. Above the waves, the continents were largely barren. No trees, no grass, no insects filled the air. The land remained a vast desert of rock and sand, shaped by wind and rain alone. Yet the presence of plants along the shores hinted at the coming invasion of life onto the land. The march toward terrestrial dominance had begun, slowly, hesitantly, but inevitably. The Ordovician was also a time of shifting climates and moving continents. Tectonic forces continued their endless reshaping of the planet, bringing together land masses and opening new oceans. Volcanic activity spewed gases into the atmosphere, influencing weather patterns and ocean chemistry. These changes created new environments for life to exploit, but also set the stage for one of Earth's first great disasters. Toward the end of the Ordovician, the planet plunged into a sudden, severe ice age. Massive glaciers formed over the southern continent of Gondwana, locking away vast amounts of water and causing sea levels to fall dramatically. Shallow seas dried up, and the rich coastal ecosystems collapsed. Many marine species, finely tuned to stable, warm environments, could not survive the rapid changes. The result was a mass extinction event, one of the first major ones in Earth's history, wiping out an estimated 85% of all marine species. Yet even in the face of catastrophe, life endured. The survivors of the Ordovician mass extinction would go on to repopulate the oceans, adapted to the new, colder world. The reef builders would return, stronger than before. Fish would continue their evolutionary journey toward dominance, and life would once again find ways to flourish in the ever-changing theater of existence. The Ordovician period, with its rich seas and early reefs, was a critical chapter in the story of Earth. It was a time when ecosystems grew more interconnected, when vertebrates began their long rise, and when the first steps toward life on land were taken. It was a world of brilliant color and intricate patterns, of triumphs and disasters, of beginnings and endings. The foundations laid during these ancient days would resonate through the ages, shaping the future of life in ways that would not be fully realized for hundreds of millions of years. Under the ancient Ordovician sun, amid the glimmering reefs and dark waters, life wrote a new and bold chapter in its ongoing saga. A story of resilience, innovation, and the relentless pursuit of survival against the shifting moods of an unpredictable planet. After the devastating mass extinction at the end of the Ordovician, the Earth entered a time of renewal. The Silurian period began, and life seized the opportunity to rebound, diversify, and venture into entirely new territories. This was an age of recovery and quiet revolution, when creatures both great and small began to explore realms they had never touched before. The seas once again filled with vibrant life, creating bustling metropolises for marine creatures. Trilobites, though diminished in variety, continued to scuttle across the sea floor, while brachiopods and crinoids swayed with the gentle currents. New forms of mollusks evolved, some with tightly coiled shells, adapting to life in the ever-changing waters. But it was the rise of the jawed fish that truly marked the Silurian as a turning point. Armored jawless fish, like the ostracoderms, still populated the seas, but they now shared their domain with the first fish capable of biting, grasping, and tearing. These early jawed fish, known as placoderms and acanthodians, opened a new chapter in the evolutionary story. With jaws, creatures could exploit a wider range of food sources, from hard-shelled prey to larger, more elusive animals. Predation pressures pushed prey species to evolve new defenses, from thicker shells to better camouflage. Tiny plankton bloomed in vast numbers, forming the base of food chains that supported increasingly sophisticated marine communities. The ancient seas thrummed with life, with creatures hunting, fleeing, feeding, and dying in an endless dance of survival. While the oceans continued to evolve, something even more remarkable was happening along the quiet, rocky shores. Life, which had been confined almost entirely to the seas for billions of years, was beginning to set its sights on the land. The very first vascular plants, equipped with internal systems for transporting water and nutrients, began to colonize the damp margins of continents. Simple, moss-like plants had edged onto the land earlier, but these new pioneers were different. They could grow taller, sturdier, and spread farther from the water's edge, raising mountains and creating new coastlines. Volcanic activity pulsed along the ocean floors, releasing minerals and reshaping habitats. Storms raged across the seas, carving new channels and stirring nutrient-rich waters. Tides swept over coastal flats, feeding the plants and creatures that clung to the margins. It was a dynamic, evolving world, with every shoreline, every reef, and every tidal pool offering new opportunities and new dangers. The Silurian was a quieter period compared to the explosive dramas of the Cambrian and Ordovician, but its impacts were no less profound. It set the stage for the greening of the earth, the conquest of land by animals, and the refinement of predatory strategies that would define the next great eras of life. It was an age of preparation and promise, where nature experimented and laid down the blueprints for the vast ecosystems yet to come. The creatures of the Silurian seas, the plants clinging to rocky shores, and the tiny arthropods braving the open air. All were the architects of a future they could never imagine. Their small, tentative steps were the first movements in a grand symphony that would one day cover the earth in forests, populate it with dinosaurs and mammals, and ultimately give rise to humanity itself. In the Silurian sun, shining over green shores and glittering seas, life found new ways to dream, to explore, and to conquer. It was a time of rebirth and quiet revolution, when the first fragile roots of the modern world took hold in the ancient stone. This chapter in Earth's history witnessed an explosion of aquatic life unlike anything the planet had ever seen. But the greatest revolution of the Devonian was not happening underwater. It was unfolding quietly, along the tangled margins of rivers, lakes, and swampy lowlands. Here, the first forests were rising. Towering plants like cladoxylopsids and early lycophytes stretched toward the sun, their primitive roots gripping the soil, their leaves, simple and needle-like, capturing sunlight and fueling a new wave of life. These forests transformed the landscape, stabilizing soils and altering the atmosphere itself. As plants spread across the continents, they drew down carbon dioxide, cooling the planet and setting in motion profound changes in climate. With forests came more complex soils, richer ecosystems, and the birth of freshwater habitats brimming with opportunity. Alongside the roots and trunks of these primeval forests, the first terrestrial animals ventured forth. Primitive arthropods, including centipedes, scorpions, and early insects, colonized the leaf litter and damp undergrowth. Breathing air, finding shelter among the plants, they began to weave the first fragile terrestrial food webs. Life was no longer merely clinging to the edges of the land. It was beginning to thrive there. Then came a moment that would echo through all of Earth's future. A lineage of lobe-finned fish began to adapt to shallow, oxygen-poor waters. Their strong, fleshy fins evolved into proto-limbs, capable of pushing against the mud and propelling their bodies into new environments. Primitive lungs supplemented their gills, allowing them to gulp air above the water's surface. These early pioneers, like Tiktaalik, were not yet fully terrestrial, but they were taking the crucial first steps toward walking on land. It was a slow, uncertain journey. Water offered support, protection, and abundant food, while land was fraught with danger and desiccation. Yet the advantages were undeniable. Untouched plants offered food. Shallow pools provided refuge from aquatic predators. And the open land, largely empty of vertebrate competitors, was a frontier waiting to be conquered. The Devonian world, though filled with vitality, was not without its perils. Near the end of the period, a series of extinction events struck, wiping out many marine species. The causes were complex, a combination of climate change, falling oxygen levels in the oceans, and possibly massive volcanic activity. Reef systems collapsed, and many placoderms vanished forever. Yet, even in the face of destruction, evolution found a way. The survivors carried the seeds of future innovation. Tectonic forces continued to reshape the continents. Euramerica, a vast supercontinent, formed near the equator, while Gondwana loomed to the south. Mountain ranges rose and eroded, their sediments carried by ancient rivers into newly forming seas. Shallow inland seas advanced and retreated with changing climates, creating ever-shifting habitats that drove the evolution of life forward. Storms swept across the coasts, carving cliffs and beaches. The winds whispered through the ancient forests, scattering spores and dust across the continents. Lightning flashed over swamps teeming with insects, and in quiet, still ponds, fish like Ichthyostega and Acanthostega tested the limits of their developing limbs. Every new adaptation, every small triumph, brought life closer to a momentous future. The Devonian was a bridge between two worlds, the familiar, watery cradle of life and the uncharted promise of dry land. It was a time when fins became legs, when gills were supplemented by lungs, and when vertebrates first looked beyond the boundaries of their ancient home. These early landwalkers could not have known it, but they were the ancestors of every reptile, bird, mammal, and human who would one day walk the earth. Their cautious ventures onto the muddy shores were the first steps of an epic odyssey that would reshape the face of the planet. Beneath the ancient sun, over a world of towering forests and teeming seas, life pushed onward. The Devonian period was a testament to evolution's relentless drive to explore every possible path, to fill every niche, and to survive against every challenge. It was an age of bold experiments, of breathtaking triumphs and devastating losses, a chapter that set the stage for the vibrant, complex world that was still to come. And in the silent shadows of those ancient forests, where strange insects crawled and the first amphibians stirred, the story of life on land truly began. The Carboniferous period opened a new chapter in Earth's story, one unlike anything that had come before. The continents were lush and green, cloaked in dense, sprawling forests that stretched across low-lying equatorial regions. Towering trees, giant ferns, and strange spore-bearing plants dominated the land, weaving an endless, humid canopy under a heavy, oxygen-rich atmosphere. It was a world of giants. Insects and arthropods grew to monstrous sizes in the thick, oxygen-saturated air. Dragonflies with wingspans wider than an eagle's soared above the forests, their translucent wings shimmering in the filtered sunlight. Millipedes the size of cars crawled slowly over the damp forest floors, feeding on decaying plant matter. The earth was alive with the hum of countless wings, the clicking of countless legs, and the creaking of ancient trees swaying in the warm breezes. Beneath this towering green world, vast swampy wetlands stretched across the continents. The waters were choked with tangled vegetation, thick mats of floating plants, and the decaying remains of countless generations. Layer upon layer of dead plant material built up, compressing under its own weight, forming the future seams of coal that humanity would one day uncover and burn. It was in these endless wetlands that the Carboniferous earned its name, coal-bearing, a monument to the incredible abundance of life. The first true forests were not just a backdrop to life. They were engines of change. They pumped oxygen into the atmosphere at unprecedented rates. Some estimates suggest the oxygen levels climbed as high as 35%, far greater than today. Fires swept across the landscape with terrifying speed, ignited by lightning and fueled by the dry, resinous plants. Yet even as they burned, life rebounded, the forests regrowing with relentless determination. Deep within these forests, vertebrates too were finding their place. Amphibians, descendants of Devonian pioneers like Tiktaalik, flourished in the damp environments. They ranged from small, frog-like creatures to massive, salamander-like predators. Some reached lengths of over 2 meters, lurking silently in the stagnant waters, ready to strike at anything that wandered too close. But even greater changes were stirring. The first true reptiles emerged during this time, animals that broke free from the chains that bound amphibians to water. Unlike their amphibian ancestors, these new reptiles laid their eggs on land, their tough, leathery shells protecting the developing young from drying out. It was a revolutionary adaptation, one that would forever change the destiny of life on Earth. The reptiles' dry, scaly skin sealed in moisture, allowing them to venture deeper into the forests and deserts that amphibians could not survive. In the skies, insects dominated, filling every available niche. Early ancestors of modern cockroaches scuttled through the undergrowth. Giant predatory griffin flies ruled the air, preying on smaller insects with precision and speed. Spiders spun their first intricate webs between the trees, and scorpions crept silently along the damp forest floors. Beneath the continents, tectonic forces continued their slow, inexorable dance. The great landmasses of Euramerica and Gondwana began to drift toward each other, setting the stage for the eventual collision that would birth the mighty supercontinent of Panjaea. Towering mountain ranges rose along the margins, their peaks weathering into sediments that fed the ever-growing coal swamps. The Carboniferous world was a planet in transition, a place where new forms of life were experimenting with independence from water, where forests reshaped the very chemistry of the atmosphere, and where insects grew to astonishing sizes under the heavy, oxygen-laden skies. Yet, as with every golden age, it would not last forever. By the end of the period, the climate began to shift. The vast, steamy swamps that had once covered much of the land started to dry out as glaciers expanded across the southern supercontinent of Gondwana. Sea levels fell, isolating the wetlands and causing many to wither away. The great coal forests fragmented and shrank, and with them, many of the towering plants and giant arthropods began to disappear. The reptiles, however, would thrive. Their adaptations for dry conditions allowed them to endure the changing world. As the swamps died, these early reptiles spread out, diversifying into new forms and claiming the abandoned niches left behind. The Carboniferous period was a moment of extraordinary innovation and abundance, a time when the Earth was blanketed in green, and the air itself was thick with life. It was a world where dragonflies the size of hawks hunted over vast forests, where amphibians ruled the waterways, and where the first reptiles quietly prepared for an age that would soon belong to them. Beneath the heavy skies, across endless emerald landscapes, life flourished, evolved, and pushed forward into an uncertain but promising future. The legacy of the Carboniferous would be written in stone and coal, a black signature deep beneath the Earth's crust, a silent testament to a world where life reached for the skies and soared and soared. The Permian period marked a world reshaped and reimagined. After millions of years of slow collision, the scattered continents finally united, locking together into a single colossal landmass, Pangaea. Stretching from pole to pole, it was a supercontinent of staggering scale, surrounded by the endless waters of the Panthalassic Ocean. The Earth's face was nearly unrecognizable. Where once lush, steamy swamps had blanketed the land, now vast, arid deserts sprawled across the interior of Pangaea. The immense size of the supercontinent meant that much of its interior lay far from any ocean, starved of moisture and battered by extremes of heat and cold. Monsoons lashed the coasts, but deep inland, searing droughts and icy winters ruled. Life, ever adaptable, responded to this new, harsher world. The amphibian, with its tall, sail-like spine, stalked the river valleys, using its sail perhaps to regulate body temperature or to intimidate rivals. Others, like the bulky, herbivorous Edaphosaurus, grazed on the tough, fibrous plants that clung to life in the arid soils. The oceans, too, bore witness to dramatic changes. Warm, shallow seas teemed with life. Ammonites, brachiopods, trilobites, and coral reefs flourished in the warm waters. Ancient sharks and armored fish cruised the coasts, hunting in the rich ecosystems that clung to the margins of Pangaea. As the Permian wore on, evolutionary experimentation accelerated. In the deserts roamed creatures like Scutosaurus, a heavily built herbivore armored against predators. Strange beasts like gorgonopsids, saber-toothed predators with long, powerful jaws, ruled the food chain. Life on land was becoming increasingly complex and diversified, exploring every available ecological niche. But beneath the surface, ominous signs stirred. The climate grew ever more volatile. Massive volcanic eruptions began to tear through the crust, especially in what is now Siberia. The Siberian Traps, one of the largest volcanic provinces in Earth's history, unleashed torrents of lava that spread for millions of square kilometers, releasing staggering amounts of carbon dioxide and methane into the atmosphere. The skies darkened. Acid rain scorched the land. Oceans grew more acidic and less oxygenated. Ecosystems began to crumble under the weight of relentless environmental stress. Then, approximately 252 million years ago, catastrophe struck, the greatest mass extinction in the history of the planet. In what has become known as the Permian-Triassic extinction event, or simply the Great Dying, over 90% of marine species and 70% of terrestrial species vanished. Coral reefs collapsed, forests withered. Entire classes of animals disappeared forever. The trilobites, who had survived for hundreds of millions of years, were wiped out completely. The causes were many and interconnected: massive volcanic activity, runaway greenhouse warming, ocean acidification, anoxia, and perhaps even deadly bursts of methane from the seafloor. It was a perfect storm of disasters, each compounding the effects of the last, creating a planet where survival itself became nearly impossible. For millions of years afterward, Earth was a desolate, barren world. Deserts spread even wider. Life clung on at the margins, small, hardy, and battered. Recovery would be slow, and the survivors of the Permian would inherit a very different world. Yet even in the midst of such devastation, the seeds of the future were planted. The survivors, particularly the early archosaurs, ancestors of the future dinosaurs and birds, would rise to dominate the next chapter of Earth's story. The Permian was a time of extremes, of unity and desolation, of innovation and destruction. It was a world that saw both the zenith of ancient life and its near-total obliteration. And from the ashes of this lost world, evolution would forge the mighty creatures that would come to rule the Mesozoic, the age of dinosaurs. Across the broken land, beneath red, sun-scorched skies, Earth stood poised on the edge of a new beginning. After the devastation of the Great Dying, the Triassic period dawned on a wounded Earth. The planet was hot, dry, and empty, a barren wasteland where life clung to the edges like stubborn moss on a scorched stone. Forests were sparse, oceans were oxygen-starved, and the scars of extinction still marred the landscape. But life, as it always had, found a way. In the wake of catastrophe, evolution raced to fill the voids left behind. Survivors of the Permian extinction, small reptiles, amphibians, and early mammals, began to diversify. In the oceans, reefs slowly rebuilt themselves, populated by new forms of corals and shelled creatures. Ammonites, resilient and adaptable, exploded into a dazzling array of shapes and sizes, reclaiming their place as lords of the seas. On land, the reptiles seized the moment. The harsh conditions favored those that could conserve water and endure extreme temperatures. Among these hardy survivors, the first archosaurs rose, a lineage that would eventually give rise to crocodiles, pterosaurs, and the dinosaurs. The early Triassic landscape was dominated by strange and primitive on Earth before or since. Over millions of years, as the Triassic unfolded, ecosystems grew more complex. Small plant-eating reptiles gave rise to larger armored forms like etosaurs, moving heavily through the dry woodlands. Towering above them were the Rauisuchians, fearsome apex predators that stalked the land on powerful legs, their jaws filled with serrated teeth. But amid these strange beasts, a quieter revolution was taking place. In the shadow of the towering Rauisuchians, small, nimble reptiles were evolving. They were bipedal, swift, and light on their feet. They were the first dinosaurs. Dinosaurs began small. Early forms like Eoraptor and Herrerasaurus darted through the undergrowth, hunting insects and small prey. Their lightweight skeletons and efficient breathing systems gave them an advantage in the hot, low-oxygen world of the Triassic. They could run faster, stay active longer, and adapt to niches that their heavier, sluggish cousins could not. At the same time, the first pterosaurs period was an age of recovery and rebirth, a world forged in fire and adversity. Their jaws were lined with razor-sharp teeth, and their senses were tuned for detecting movement in dense undergrowth. These were not primitive reptiles. They were apex predators with complex behavior and powerful bodies built for the chase. In the skies above, the pterosaurs expanded in size and diversity. Some had crests, some were no larger than modern birds, while others, like Rhamphorhynchus, had long tails ending in stiff veins. They soared over coastal cliffs and inland lakes, diving to catch fish or scavenging carcasses on the beaches. But this was also the time when the earliest true birds began to appear. From small feathered theropods, the first birds emerged, creatures like Archaeopteryx, caught between two worlds. With wings feathered like those of modern birds, but still bearing claws and teeth, they fluttered through the canopy, gliding between branches. They were evolution's first tentative experiment in powered flight from land-dwelling dinosaurs. Beneath the waves, the seas teemed with giants. Ichthyosaurs swam like swordfish, sleek and torpedo-shaped, their huge eyes adapted to the dim light of deep waters. Plesiosaurs, with long necks and barrel-shaped bodies, paddled through the shallows, their mouths bristling with needle-sharp teeth. Ammonites spun through the currents in their coiled shells, some glowing with iridescent colors, others as large as beach balls. Reefs, formed by sponges and corals, burst with life. Crabs, starfish, and ancient squid-like creatures thrived in the warm, shallow waters. Turtles and marine crocodiles patrolled the coasts, and the first marine ecosystems resembling those of today began to take shape. In the Middle Jurassic, as the continents drifted further apart, ocean levels rose. The climate became even more humid, turning many regions into swampy lowlands and shallow inland seas. Rainforests spread far and wide. In this verdant world, dinosaur diversity exploded. Ecosystems grew more complex. Different species filled specific roles. Some dinosaurs grazed low ferns, others browsed the treetops, some scavenged, while others specialized in burrowing or even gliding. The evolutionary tree of dinosaurs grew thick with branches, each leading to new forms more specialized than the last. By the late Jurassic, the giants ruled without question. Brachiosaurus towered above the canopy, its nostrils perched high on its head, breathing the warm, moist air as it browsed from treetops inaccessible to any other creature. It walked with forelimbs longer than its hind limbs, giving it a sloped posture, almost like a giraffe of the Jurassic world. Apex predators like Allosaurus challenged even the giants, attacking the young, the old, or the weak with coordinated precision. They were intelligent, fast, and relentless. In packs, they were the terror of the open plains. And among the smaller theropods, new features began to appear. Feathers, hollow bones, and bird-like hips. While still grounded, these small creatures were becoming more agile, more intelligent, more adaptable. In their lineage lay the future birds, but in the Jurassic, they were nimble hunters darting between ferns and logs. As the Jurassic period neared its end, volcanic activity increased once again. The continents continued to drift. Sea levels rose and fell. Climates shifted, and certain habitats began to vanish. Yet dinosaurs remained resilient, evolving with each change. The Jurassic was the golden age of dinosaurs, a world of titans and hunters, of steaming forests and deep blue seas. It was a time of innovation, expansion, and dominance. Never before had a group of animals so completely ruled the land, the air, and the ocean. From the misty valleys of ancient Pangaea to the craggy coastlines of newborn continents, dinosaurs were the masters of a vibrant, teeming planet. And even greater giants were still to come. The Cretaceous period was Earth's final act in the age of dinosaurs, and it was the longest and most dynamic of the three Mesozoic chapters. It began with warm temperatures, rising seas, and life spreading across the globe. Over the next 80 million years, this world would transform again, splitting continents, spawning flowering plants, birthing evolutionary giants, and eventually ending in fire. As the Cretaceous dawned, the continents were continuing to drift apart. North America was splitting from Europe. South America was pulling away from Africa, and India was drifting toward Asia like a runaway ship. These movements created massive inland seas and new coastlines, which in turn built rich and diverse habitats. Shallow seas flooded entire continents, dividing once unified ecosystems and forcing life to adapt or perish. Dinosaurs ruled more completely than ever before. By now, their diversity had reached its peak. Towering herbivores like Argentinosaurus stretched over 100 feet long, dwarfing even the giants of the Jurassic. Their necks reached deep into the forest canopies, their massive bodies moving slowly but surely across the earth, consuming tons of vegetation each day. Predators evolved to match their scale. The most infamous of them all, Tyrannosaurus rex, emerged in the final chapters of the Cretaceous. Its skull was built like a sledgehammer, packed with bone-crushing teeth and powerful jaw muscles. With every bite, it could tear through flesh and splinter bone. Despite its size, it was fast and smart, an apex predator with few equals. But T-Rex was not alone. Other deadly carnivores roamed across the Cretaceous world. In Africa, Spinosaurus dominated the river systems. It was longer than T-Rex, with a crocodile-like snout, conical teeth, and a giant sail rising from its back. It hunted fish in the swamps and river deltas, using its strong arms and sharp claws to trap prey beneath the water. Smaller, more agile theropods were everywhere. Velociraptors, though smaller than their Hollywood image, were cunning pack hunters armed with sickle-shaped claws and keen intelligence. Dromaeosaurs, their close relatives, displayed complex behaviors and often bore feathers, proof of their evolutionary link to birds. In fact, birds had now fully evolved from their dinosaur ancestors. Creatures like Hesperornis swam in the Cretaceous seas, using wing-like limbs to dive like modern penguins. Enantiornithines, the most widespread bird group of the time, flitted through the forests, sharing the skies with pterosaurs that had grown to enormous sizes. Some, like Quetzalcoatlus, spanned over 30 feet from wingtip to wingtip and soared across vast distances like modern-day gliders. Beneath the canopy, the forests themselves were changing. This was the age when flowering plants, angiosperms, first bloomed. Before the Cretaceous, forests were dominated by conifers, cycads, and ferns. But now, flowers burst across the landscape in vibrant waves. This evolutionary leap transformed entire ecosystems. It attracted new types of insects, bees, ants, butterflies, and fostered coevolution between pollinators and plants. It was the beginning of the ecological relationships we see today. Alongside them, the first grasses began to spread across plains, hinting at the future rise of grazing mammals. Flowering plants changed the diets of herbivores too, and in turn, reshaped the structure of dinosaur communities. Some dinosaurs, like hadrosaurs, also known as duck-billed dinosaurs, evolved complex chewing systems to take advantage of this new food source. They roamed in massive herds, communicating with honking calls and elaborate crests. Ceratopsians, like Triceratops, developed huge frills and horns. Their skulls were among the most elaborate in all of natural history. Some used them for defense. Others likely used them for species recognition or mating displays. Each genus bore its own unique pattern, an evolutionary arms race of ornamentation. Ankylosaurs, armored and low to the ground, patrolled the forests like living tanks. Their bodies were wrapped in bony plates, and many bore heavy tail clubs capable of shattering bone. They stood their ground against even the fiercest predators. In the oceans, the seas of the Cretaceous were just as dangerous as the land. Mosasaurs, giant marine reptiles with double-hinged jaws and flippered bodies, patrolled the deep. Plesiosaurs continued to thrive, their long necks snaking through coral reefs in search of fish. Sharks circled beneath the waves, some evolving into new forms with bizarre teeth designed for slicing through tough prey. Coral reefs, teeming with life, stretched across the tropics. Ammonites remained abundant, their spiral shells spiraling into new forms. Marine turtles, sea urchins, and crabs scuttled through the shallows, while plankton blooms painted the water in shades of green and blue. Life in the Cretaceous was thriving, yet the planet was not calm. Beneath the surface, volcanic forces were building. The breakup of Panjaea triggered massive lava flows and tectonic upheaval. Greenhouse gases surged into the atmosphere, raising global temperatures and changing ocean chemistry. The poles remained ice-free. Warm, shallow seas bisected continents. Many regions became swampy, rich in nutrients but prone to stagnation and low oxygen. Still, the world remained vibrant. Life found ways to flourish in every corner, on land, in the air, and across the seas. But then, in the final chapter of the Cretaceous, a shadow loomed over the future. 66 million years ago, a 6-mile-wide asteroid slammed into what is now the Yucatan Peninsula in Mexico. The impact unleashed energy greater than 1 billion nuclear bombs. Shockwaves flattened forests for hundreds of miles. Firestorms raged across continents. Molten rock and vaporized sulfur were ejected into the atmosphere, darkening the skies. Acid rain fell. Global temperatures plummeted. Food chains collapsed. The age of dinosaurs, the rulers of the Earth for over 150 million years, came to a sudden and violent end. But even in extinction, they left behind a legacy. Their closest descendants, the birds, survived the catastrophe. And from the ashes of the Cretaceous, new forms of life would rise. The Cretaceous was a world of unparalleled complexity and beauty, where the evolutionary story reached one of its greatest climaxes. It was a world teeming with color, diversity, and majesty, and its sudden ending was one of the most pivotal moments in the entire history of life on Earth. 66 million years ago, the age of dinosaurs came to a cataclysmic end, not in a slow decline, but in an instant of planetary violence. The world was alive with color and noise. Massive dinosaurs roamed vibrant forests. Giant marine reptiles ruled the seas. Pterosaurs soared across sunlit skies. Flowering plants bloomed across continents, and insects buzzed between their petals. Life had conquered every corner of the Earth, but everything was about to change. High above the atmosphere, an asteroid 6 miles wide hurtled through space at over 40,000 miles per hour. It had traveled millions of years through the cosmos, its destination, a shallow sea off the coast of what is now the Yucatan Peninsula in Mexico. The moment it struck, time itself seemed to pause. In a single second, energy equivalent to more than 1 billion nuclear bombs exploded into the atmosphere. The asteroid punched through the crust and vaporized upon impact, sending a column of molten rock, ash, and sulfur high into the stratosphere. Shockwaves radiated outward at hypersonic speeds, flattening forests, boiling the seas, and setting the sky on fire. The impact crater, now buried beneath the Earth and known as the Chicxulub crater, spanned more than 90 miles wide and reached deep into the planet's crust. For thousands of miles in every direction, the force of the explosion ignited wildfires, earthquakes, and tsunamis taller than skyscrapers. Within minutes, entire ecosystems were in collapse. But the worst was yet to come. As the dust and debris rose into the atmosphere, it began to encircle the globe. Thick clouds of ash and vaporized rock blocked out sunlight, plunging the Earth into darkness. Temperatures dropped rapidly. Photosynthesis ground to a halt. Plants withered and food chains broke apart. Herbivores began to starve. Predators followed soon after. In the oceans, the same pattern unfolded. Plankton, the foundation of the marine food web, died off as sunlight vanished from the surface waters. Without plankton, fish populations collapsed. Marine reptiles, mosasaurs, plesiosaurs, and ammonites vanished. The reefs turned pale and empty. On land, the devastation was equally absolute. Towering dinosaurs from the mighty Tyrannosaurus rex to the armored Ankylosaurus succumbed to starvation, exposure, and fire. The forests that once echoed with the footsteps of giants fell silent. Entire families, species, and lineages were lost in a geological instant. By some estimates, over 75% of all life on Earth perished. This was the fifth mass extinction in Earth's history, the most famous and among the most devastating. It ended not only the reign of the dinosaurs, but also the age of reptiles that had dominated for over 150 million years. But not everything died. Some creatures found refuge in the shadows. Burrowing mammals, small and warm-blooded, survived underground. Birds, the only living dinosaurs, endured by taking shelter and finding food in the altered landscape. Crocodiles, turtles, and some amphibians persisted in water and mud. Insects, fungi, and early flowering plants adapted to the darkness. And in the quiet that followed the cataclysm, evolution began to rebuild. The impact left permanent scars on the planet. Traces of it can still be found today in a thin layer of clay called the KT boundary, rich in iridium, a rare metal often found in asteroids. This layer exists across the entire planet, a line drawn through the rock marking the moment life nearly ended. The crater itself lay buried for millions of years beneath layers of sediment and water. Only in recent decades did scientists confirm its existence, using satellite imaging and geological surveys to uncover its true size and shape. The discovery of the Chicxulub crater provided the final piece of evidence in one of science's greatest mysteries. It confirmed what had once been a controversial theory, that a rock from space had ended the age of dinosaurs. But the story of extinction is also a story of renewal. In the silence after the storm, mammals began to rise. Forests returned, oceans warmed, and new species emerged to fill the empty niches left behind. The world was no longer ruled by reptiles, but it was not dead. The asteroid reset the evolutionary clock. It opened the door for an entirely new age, an age where tiny, shrew-like mammals would one day become whales, bats, primates, and eventually humans. The impact at Chicxulub was not just the end of a chapter, it was the beginning of everything to come. And even now, in every bird that sings, in every flower that blooms, and in every mammal that walks the earth, the legacy of that impact lives on. In the aftermath of devastation, the earth was quiet. The skies, once filled with the shadows of pterosaurs and flocks of birds, were dimmed by lingering ash and dust. The seas, once teeming with giant marine reptiles and ammonites, were now still and eerily empty. Forests had burned, plains had vanished, life had been pushed to the brink. But extinction is never the final word. From the ruins of one world, another always begins. In the weeks and months after the impact, the Earth's atmosphere slowly began to clear. Sunlight returned in pale golden streaks. Temperatures began to stabilize. Rains fell once more, and in their wake, green returned to the land. Tiny shoots pushed through scorched soil. Spores and seeds, carried by wind and time, found new ground to grow. The first to reclaim the landscape were ferns, ancient survivors of every extinction event. A world once dominated by dinosaurs was now carpeted by fields of low, leafy green. This period, known as the fern spike, marked the planet's slow rebirth. With the return of plants came insects. Beetles and ants, survivors of the apocalypse, began to recolonize the forests. Fungi flourished in the decay, breaking down the dead and recycling nutrients back into the soil. And from the undergrowth, mammals began to rise. They had been there all along, small, warm-blooded, quick and clever. Many had lived underground, safe from fire and falling ash. They fed on seeds, insects, and whatever else they could find. In a world emptied of giant predators, they found opportunity. They began to diversify. Some became larger. Others adapted to climb, burrow, or swim. Within a few million years, these creatures would radiate into an astonishing array of forms. Their story was just beginning. The age that followed is called the Paleogene, a time when mammals would become the dominant life forms on land. But the ghosts of the Mesozoic never truly vanished. The legacy of the dinosaurs lives on in birds, the last surviving lineage of theropods. Their hollow bones, feathers, and nesting behaviors are echoes of their ancient ancestry. Every songbird, eagle, penguin, and pigeon carries the evolutionary memory of raptors and tyrants. In the oceans, though the giant reptiles were gone, their ecological roles were filled by new marine mammals. Whales, dolphins, and seals would eventually return to the water, reclaiming the seas in a new form. Reefs rebuilt, fish populations returned, and new predators emerged to patrol the depths. On land, the ecosystems slowly rebuilt. Flowering plants, which had flourished in the late Cretaceous, continued their expansion. They co-evolved with insects, leading to explosive growth in biodiversity. Forests grew taller, denser, and more complex. Life was no longer what it had been, but it was no less magnificent. Over the next 66 million years, mammals evolved into forms no one could have predicted. Elephants with trunks, bats with wings, cats with retractable claws, and humans with minds capable of understanding deep time. They walked the same ground that once shook under the feet of sauropods. They breathed air enriched by plants that had first emerged in dinosaur shadows. They gazed at stars that once watched the Mesozoic night. And deep beneath their feet, the rock still told the story. Layers of sediment hold the imprint of ancient leaves, the footprints of vanished reptiles, the bones of creatures that once ruled and fell. The Earth remembers. Today, scientists use those layers like pages in a book, reading the fossil record, analyzing isotopes, uncovering clues written in stone. Each discovery brings the Mesozoic world back into focus, a time when the continents moved like puzzle pieces, when reptiles ruled with unimaginable diversity, when catastrophe reset the balance, and when resilience wrote a new chapter. The legacy of the Mesozoic is not just in the creatures that lived and died. It is in the very idea that life can rise, fall, and rise again. It teaches us that dominance is temporary, that survival requires adaptation, and that even in the face of extinction, life finds a way. And perhaps most profoundly, it reminds us that the world we know is only one version of what Earth can be. Before mammals, before humans, before cities and civilizations, there was another Earth. An Earth shaped by fire, water, time, and impact. An Earth that belonged to creatures whose bones now sleep beneath our feet. We walk on their ruins. We live in the world they made possible. The age of dinosaurs may have ended, but their story lives on, in fossils, in science, and in every beating heart that descends from their legacy.